To find the blue area, first of all, we are going to take a some segment, and I'm taking the segment from A. I'm taking I'm taking to the point where we have where they attach a equilateral triangle and a semicircle. And now I'm taking another segment from point A here, and I'm taking an altitude to the point D. So now let me take here one pen, and we want to find the blue area of the equilateral triangle. And what do we have here now? Now we can see here this we have a big triangle ADC. We have a small triangle D to this point. Let's say to point P here, DPC, and we have a medium triangle ADP. If we are looking this triangle here, the altitude we already know here is a 90 degree. And what do we know else? The else we know here, this segment here from B to C is A, but the half from D to C is equal with A divided by 2. And now if we are looking at equilateral triangle, the height here is going to be equal with A over 2 times square root of 3. That's what we know. But as we see here, the relationship between the sides of the triangles here indicates the half of the triangle, equilateral triangle here, is a special triangle with degree 30, 60, 90 degree. So this is a 30, 60, and 90 degree. But because we have all three triangles in the same place, and we have here, for example, is 90 degree, because whenever attaches the semicircle to the triangle here, to this line, it creates a 90 degree. And because we have this situation, it means all the three triangles are similar. And because all the three triangles are similar, it means each one is a special triangle 30, 60, 90 degree. If you're looking for hypotenuse here, is going to be A, from A to C. But if you are looking from P now, this is A over 2. From P to C is going to be A over 4. And this side here of the small triangle, the longer side, is going to be equal with A square root of 3 divided by 4. But in effect, this here is from A to P, this is the radius of the circle. And now we can find the area of the semicircle. So the area of the semicircle, okay, semicircle, let me write the S, is going to be equal with 1.5 times pi times r square. The area of the semicircle is going to be 1.5. Here is a pi, and the r square. We have r square because the radius A square root of 3 is divided by 4, and everything here is square. And area of the semicircle is 1.5 pi, and here is a square times 3 but 4 square is a 16, and that's what we have here. If we are simplifying a little further, area of the semicircle is equal with 3a square divided by 32 times pi. Okay, and area of the equilateral triangle, so we have let me write it and everything here. So area of the triangle here, equilateral triangle, is 1.5, and we have the base. Let me write base times height, which is 1.5. Base is A, and height, which is altitude, is A times square root of 3 divided by 2. If we are simplifying a little bit, so the area of the triangle is equal with A square divided by 4 times square root of 3. But now to find the blue area here, we have to subtract from equilateral triangle area the semicircle area. And if we are doing that, we have now in this case here, so let me write here. So the blue area, AB, is going to be equal with the area of the triangle minus the area of the semicircle, which happens to be here. A square divided by 4 square root of 3 is minus 3a squared divided by 32 times pi. If we are simplifying a little bit further, the blue area is going to be here a square, both of them, the greatest common factor for both the terms is a square divided by 32, and this can be a times 4, which is here a times square root of 3, and here is a minus we have here 3 pi, minus 3 pi, and everything is in unit square, so it can be anything, inches square, meter square, centimeter square, or whatever it is, but is a unit square. And here I'm stopping.